Robin Vincent and welcome to Molten Music Technology. Today we are building the TSSSS Start Here. Yeah, I know it's a terribly named synthesizer, but what it is a great first attempt DIY little synth project. Only cost 50 quid. They got a whole bunch. There's a link in the description so that you could get one and you could follow along, because the idea of this video is to provide some kind of build tutorial / experience while at the same time providing some homeschooling for my oldest, Alfie. Say hello, Alfie.
Hello.
So for this video, we're between us going to get stuck in. We're going to treat it as if it's your first ever synthesizer build, which it kind of is for Alfie, although we did click something together last year, I seem to remember. But this, working with proper PCBs and bits and pieces, could be very interesting. And at the end, hopefully, we'll have a fantastic video and a fantastic little synthesizer based on the Meeblip Anode or something, but we'll find out what it sounds like at the end with a bit of luck, assuming that it all just works. So as I'm going to treat this as kind of a tutorial or an introduction for you to start your first DIY project, let's begin just by having a little tiny look at the equipment that you may need to do such a thing. Now, I should stress that you don't really need anything. I mean, a soldering iron, obviously, because it's a project that involves soldering components to a board. So you will need at least that. But there's a few other bits and pieces you could have at the same time. So let's just have a quick look. So over in our corner, Alfie, point at things and I'll tell you what they are. That is the soldering iron. Pick it up. Pick it up. This is the hot end. You don't ever touch the hot end, only ever hold it by its handle. These are wire cutters, snippers, whatever you like. They're for cutting off the legs of components. We have a regular pair of needle nose pliers for pulling stuff. Potentially, might not need that. This is interesting stuff. It's not necessarily necessary, but it's useful for getting solder off the end of your soldering iron if it's globbed all on the end. But otherwise, just use the sponge that probably came with your soldering iron holder thing. Now, we're using quite a posh soldering iron, costs about 100 quid. Don't need to have anything quite that posh. You can have a 20 quid soldering iron from Amazon or from Argos or wherever it is you got it from. It will work. It just may take longer to heat things up and you might have to work a bit slower. We then of course have some solder. You may find that you can only get hold of lead-free solder, which is fine. It just takes a little bit longer to heat up, whereas this is leaded software and so it's nice and quick. Solder sucker, useful solder sucker. So if you really mess things up, you can put this up against the solder, heat it up and remove it with a little press. It's really very satisfying doing that. We do have a grabber and magnifying glass array thing, but we're probably not going to use that very much. We're just going to have it out on the table, soldering directly on it, no messing about. Now we're going to be following the guide that's on the TSSSS.org website that shows you how to do it, or at least we hope so. We've only just started on page 1 and we're going to work our way through, and hopefully that should tell us everything we need to know in a lot of detail. Now, many people often say that a good way to practice soldering is to get a bit of old PCB from somewhere and just, you know, practice soldering things together. But I would probably suggest that you don't really have bits of old PCB knocking around. I mean, not unless you're going to go and break some piece of electronics and give that a go. So the likelihood is that this is the only PCB that you have. So my advice would be, just get on with it. Don't mess about practicing. Doesn't matter, just give it a go. And if you don't get it right on the first one, you just keep doing it till you get it right. Suck the solder off, do it again, suck the solder off, and we'll have a look at what a real solder joint is supposed to be. But it's one of those things which is self-evident and kind of obvious. You're trying to connect a piece of board that has a ring of metallic conductible material on it to a leg of a component. Those two things have to connect to one another, and we connect them together with this liquid metal stuff. So it becomes quite obvious whether that's worked or not, and you'll find that as you solder, it becomes easier because you recognize what it looks like, how it feels as these things go together, the amount of smoke that's generated. All of these things are the same every time you do it. So don't worry about practicing. Let's just get stuck straight in. First thing we should do is tin the end of your soldering iron. What does that mean? That means you just get some solder and you melt it on the end. that's pretty much it really. So that the soldering iron, which is made of metal, then has a very thin covering of solder on the end, which just helps it work better. So first of all, Alfie, pick up the soldering iron, and what you want to do is just melt some of the solder on the end and the tip, up and down the tip a little bit of the soldering iron. Dab it into the sponge, into the wet sponge. It will fizz. Now you should see the end is a lot shinier. So open the bag. Okay, so it's difficult, you know. These teenagers, these high schoolers, they really do need a lot of help opening bags. The other thing you may need is a Stanley knife. Now the Start Here synthesizer consists of two PCBs, a green one and a red one. Red one goes on top of the green one. So the red one kind of contains all the controls, all the knobs and switches, and then the green one contains all of the circuitry and the IC and such like. Now one thought I had about the whole Start Here name is that what this actually does is it gives us an opportunity to finish our first little mini DIY synthesizer and then name it ourselves. So that's quite exciting. That's what we're going to do. Let's have a look at what we've got. See if you can pull out things and put them into little piles of different bits. So what we could do is have a look at the bill of materials on the screen and just check that we have everything that we should have. So part number one is a diode, D1, that's that. Good. Then we've got resistors, a whole bunch of resistors. Now these are the resistors. They look like little slugs of stuff with bands of colour. Then it's capacitors. Now these little fellas here, these little orange blobs are capacitors, but you also have two different sorts. These are also capacitors. What's next? The crystal. This?
Yeah.
No, I don't think so. Is that a switch, did you say?
Yes, button.
Well, the crystal, I don't know what that looks like. It could be anything at this point. No, it's probably this. So that, I reckon, is the crystal. There's no labelling on the actual parts, so we're going to have to work that out through the build guide, which does give us photographs of everything, so that should be fine. Next you've got the ICs, of which there should be 1, 2, 3, 4. 1, 2, 3, and then there's the big one. Then there's a transistor, which is this fella here. Transistor's always got 3 legs, that's the giveaway for a transistor. Then headers. These are generally called headers. Now there seems to be a couple of those, and then a couple of these. A MIDI in, which is that socket there. A jack socket, which is that fella. Now it talks about 3 other capacitors, which are probably these larger ones. Mini USB, which is that. Push button, which is that. There's a S1 MIDI in, do not place, it says. Not sure what that refers to. Then there's an LED, which is that one. It's the light. A bunch of pots, what is in there? And a couple more header sockets. So I think we have everything. So the first thing we need to do is the diode. There we go, that's the fella. Now a diode is very small, but it's a diode is something. Oh yeah, see, this is it. This is going to be the interesting thing about me attempting to teach somebody else to solder, is that I'm like explaining things that I don't fully understand myself, because I should stress that I'm not an expert in electronics or soldering or making synthesizers. I've just done a fair bit of it now, so I've got a bit of experience, and I'm trying to get that across to this fella a little bit. So I'll do my best to say what things are and give the reasons for their existence, but most of it we're just going to work through. And I'm going to stop talking about all these bits. We're going to get down to the actual soldering. But a diode is a component that lets stuff go through one way, so it has to be the right way around, and that should be marked on the PCB. So if you can find the place on the PCB where it's supposed to be, this is D1.
There.
Okay, so it's there on the PCB. It shows you a line on it which matches the black line. Perfect. So what you need to do is to bend the legs. Really, you see how far apart the two bits are? So it needs to be right close to the edge of the component.
This is hard. Look at that.
Yeah. And then stick it through the right way round. That's it. And underneath, just bend the legs left and right a little bit.
Which way?
So that it doesn't fall out, so that it stays where it is. So if you bend...
Like that?
Yeah, but what, generally speaking, what we do is just bend them out like that.
Oh, okay.
That way it's sort of secure in there, yeah?
Yeah.
Now, perhaps what I should point out here is that generally on a PCB of this nature, in a kit, that everything is labelled. You have what's called a silkscreen print over the top that prints all the components. And the numbers and the letters on here refer to the BOM, or bill of materials, that's in the build guide. At the very least, when you get a kit, any sort of kit, you should get a printed circuit board that's been silkscreened with labels, plus a sheet of paper that names all of the components and what their name is on that board. That's the minimum you need, really, without having to get into circuit diagrams and bits and pieces. But with those two bits of information, you should be able to build something. With this product, TSSSS have provided a build guide with photographs and step-by-step instructions, which is brilliant. Makes it so much easier because you can identify all of the components by looking at photographs of them, so you know absolutely that you've got it right.
Do we get to solder now?
Yeah, let's do our first bit of soldering. So, it says bend the legs down and insert it into the board. The other vital piece of equipment, of course, is safety spectacles, because solder can spit. It can spit and hit you in the eye. That would be bad. Very, very bad for you. Very, very bad for the boy. Also, when snipping legs off components, this is the thing that happens to me the most, is that they tend to go ptoing and they can hit you in the eye as well. So, safety specs. Very important. So, here we go. Our first bit of soldering. What we'll do is I will do a leg and then you do a leg. Okay?
Yeah.
So what we're trying to do is connect that ring of whatever metal that is, silver stuff, to the leg.
Okay.
So what we do, take our soldering iron, remember it's hot.
Yeah.
Take a bit of solder. So we place the soldering iron, not on the leg.
Will it melt the leg?
No, it won't make the leg melt to the leg, but we want to heat up the pad enough so that the solder will flow all over the pad and attach itself to the leg. Now, ideally, I guess the soldering iron should be on the leg and the pad, so it heats up both those things. But with it there, just for a moment or two, you should be able to push the solder into it, and you should see it flow around. And when you release, you should have a nice kind of little mountain that's attached itself all the way around the pad and all the way around the leg.
Mm-hmm.
So it's connected on all sides,
yeah.
that way, and therefore makes a good joint.
Okay.
So give that a go. Heat up the pad first. You can hold the PCB with your finger, of course. So place your soldering iron first. That's it.
Well,
so
could it melt the board?
Shouldn't do.
Okay.
But you should be on the metal, so that should be fine. And then you're not trying to put the solder onto the end of the iron, you're trying to put it onto the rest of the pad. Because it will just melt straight to the soldering iron. You want it to be melting to the metal. So
like that?
Yeah, I'd say a little bit more. Push in a bit more. That's it. So you take the solder away first, and then take the soldering iron away, so that the solder doesn't end up stuck to it. Just put that away. Now, if you have a look and compare the two. Do you see anything that's different between the two?
Yours is more like bigger.
Yeah, so what I would say, I mean, you did a great job, absolutely, but I would suggest it just perhaps could do with a little bit more. I mean, it's there and it's connected, but if you can just add a little bit more, I think that would make it more secure. So soldering iron on first.
Wouldn't it melt?
Yeah, it's going to melt and it will move about a little bit. You just want to add a little bit more to the flow so it flows around. That's it. Let go.
Solder wafers.
Yeah. I think that looks a bit better. Cut legs off nice and close. To
Really
the bottom.
close though.
Yeah, nice and close to the bottom. See, and it hit you straight in the face.
Did it?
Didn't it?
No, I don't think so.
Oh, okay. There we go. Lovely.
Okay.
So let's move on to our next bit on the guide. Resistors. Now it says that the value of the resistors is marked by coloured bands. And it suggests that you should Google them. Oh, right. Okay. But they're just going to show us in photos which ones they are. So
Not those.
what we're going to do is we're going to place all the resistors in the order that it suggests on the page. So if we go back to our silkscreen side. So take the tabby bits off. Find R12. Now resistors don't need to be one way round or the other. They go in either way. So stick it through and then do the leg splaying underneath. And then we'll add all the rest of the resistors.
Yeah?
Yeah, so
Oh yeah.
twang the legs.
So wouldn't it get in the way of those ones?
Possibly, but we're not doing the whole lot at once.
Okay.
So now it's looking for 100k.
Oh,
So you need to
Okay.
find all of those. We've got R5, R7, R8, R10, R11. Alright, so let's do the ones that are in. I mean, we could put the rest of the resistors in, but alright, it's a good place to stop. So we turn it over. I mean, you could use the clipper arm thing, array thing we got over there to hold it up so that you can angle it properly. You can get all sorts of different vices to stick on the desk to hold things, but all you need to do is just have it in a way that's comfortable for what you're doing. So for instance, trying to get the soldering iron into there might be more difficult, so just turn the board around and get it in. If you need to lift the legs up a little bit to make that easier to get to, do that. You know, you don't have to. You just want to use it in as comfortable way as possible in what works for you.
okay.
So yeah, give it a go. Remember what we did last time? Tried to
Yeah.
put enough solder on.
So it's like going to mount it.
Yeah. Now it doesn't appear to be heating up. Just pull the solder away for a second and just adjust your position on it slightly. Maybe it's not completely on, maybe, you know, so just adjust your lean angle or what you're attached to a little bit, and then try again. That's good. Yeah, it looks pretty good.
Oh, keep going.
Yeah, we'll do the rest. So do one, do one side then the other side of each of them.
Should I be doing a bit more than that?
It looks pretty good to me, mate. It looks pretty good.
Okay.
Yeah. Now that looks pretty awesome.
There's a big bubble on the other side.
Have a look. Yeah, well that's interesting because that's the solder coming through from underneath. So in one or two places you perhaps used a bit too much solder. So that's
Okay.
come through and made a bit of bubble on the other side. But providing it's not touching another component, it's completely fine. It looks great from this side. Great, snip the legs off
Oh yeah.
and then on to the next bunch.
How many of these do I have to do?
That many.
Oh, okay.
I don't know about this being a teacher lark, because it just means you don't get to do the fun stuff. You get to watch somebody else do the fun stuff. What's the point of that?
So how does sticking it to the metal make music?
That's a deep question. I don't know. There's some kind of circuit in here, a collection of components which creates a sound and shapes that sound. And in order to do that, through the controlling of voltages, we have to create a circuit which applies various restrictions and routing on that signal on those signals, and that's what we get out the other end. So these things all contribute to the controlling of that voltage through the circuit that then comes out of the audio socket into your ears.
Okay. So what next?
So these resistors. So if you can find these 3 lots, and then rather than measuring them, we'll just go off what the photo says.
Okay, R2 and R4.
So let's have a look at all the resistors that we have. So these ones here, they've got the yellow band, so they're probably these 1 meg ones.
That one has the one at the end.
Is it yellow, brown, black, orange?
Yes.
Yes. So that's the 470.
And then
we're going to have the
those
3, which are the 10k,
mhm.
and one more, which should be the grey, black, I don't know, orange, brown or something.
That one.
That one. Cool. Right. So let's get these right.
So which one?
So start off with the 2 browns, black and brown, or 2 reds, black and brown, depending on how you look at it. Can I zoom in on that? So it's 2 reds, 2
Not
blacks,
that one.
brown.
Oh, the one I'm holding.
One you're holding. So those 2.
Mhm.
Those are R2 and R4.
Oh, they got little bits of paper in the end.
That's all right, because you'll be cutting that bit off, won't you?
Oh yeah.
Nice. Let me have a quick look. I won't want to keep going over every single one, because at some point we're going to have to just assume that you're doing it all right.
Yeah.
And I think you are. Oh, that's pretty good, mate. That looks pretty good to me.
Okay, what next?
Have a look. Compare yours to that picture. Do they look about the same?
Yep.
Cool. Scroll on.
Capacitors.
So capacitors are marked with their value either by robots with incredibly good eyesight. Yes, I know that feeling. For your convenience, the photos below show the values. Phone cameras are a great way to zoom in on the markings.
104 K5M.
So we're looking at the orange blob ones.
Orange blobby one.
So we want the ones that say 104,
Mm.
and there should be 1, 2, 3, 4, 5 of them.
That's one I was just gonna.
So you probably find the ones that all look about the same.
They're really short.
Now the instructions suggest that using a phone camera is a good way of zooming in
104.
on a thing so that you can see what they are. And yeah, that's a bleedingly good tip. Look at that. I can see it on my phone.
Okay.
Great, let's put all of them in. There's not that many. So there's one which is a 2N2F.
This one says C1K222.
Does it? Yeah, so this is 22 squiggle, not 222, this one.
That one's one squiggle free.
Alright, so we're going to have to do this by some kind of process of
But
elimination.
it must be this
See, I don't know that this is any more useful.
103.
That's a 103. So let's put that one in. I've lost my eyes. Oh dear, dear, oh dear. So using a little bit of process of elimination, I think we got around it. Those capacitors are hard. Really difficult to read. Always difficult to read those things. So that's all of them in.
Solder time.
Yeah, it doesn't matter which way around they are.
No.
Solder away.
A bit messy
What, here?
there. Yeah.
So
Are they stuck together?
you might have a couple that are stuck together there.
Is that bad? Don't need to solder suck them.
Yes, you may do. Because you've spread these legs across each other, that's part of the problem, I imagine. So yeah, let's get our solder sucker out. So what you do,
What happens if I suck my finger?
nothing, you just get a circle on your finger.
Ooh.
Brilliant. We will have to do that at least once. So yeah, so what you do is you heat up the solder.
Yeah, okay.
Heat up solder, and then you put this, so you press this down, so it's loaded, ready to go. That's the button. You put it up against, this is heat resistant.
Yeah.
Obviously you can melt it if you try hard enough, but you put that up as close as you can. You're heating up the solder. So one hand with this, one hand with your soldering iron, and then you go pop and it should come away.
Okay.
That's the plan. Give that a go.
Try. Is it ready?
Yeah, it heats it up straight away. Push it down again.
Oh. So if they're touching, is that bad?
Yeah, because then it's
They would send the power
current.
through each other.
Yeah, the current will go through the easiest way it can. So if it's not, if it can bypass the component, it absolutely will. So that leg there needs resoldering.
Okay.
Yeah, because you pulled all the solder off it.
Yeah.
And if we keep it this way, it shouldn't touch the other one. So yeah, do that a go. Give that a go, and then snip them all off.
Yep. Okie dokie.
So does it look similar?
Yep.
Yeah, fabulous. Right, what's next? Okay, crystals and ICs. So this comes in a little protective thing to stop the legs getting bent, which is good. That just pops out. So we have this, and do you want to get the other ones? Yeah. And the little crystal as well.
Oh yeah.
So with ICs, integrated circuits. So in here is a whole bunch of jiggery pokery stuff
Okay.
that does a load of things for us, rather than having to build a huge circuit. Lots of little circuits are packed inside here that we can use to do things. So these have to be a particular way round. So you see this notch on it there.
That's lined up with the thingy on
That
it.
lines up with that on there, yeah. So that should just drop in there.
Do we have to solder all of those?
And you've got to solder the whole lot.
Wait, I think that has a bit of solder.
Oh, oops. So yeah, that's going to have to go in there.
I'm gonna have to solder stuff.
Except that you've got a which is there.
How did I get out of there?
Oh look, there's a big glob of it on there.
Sorry.
There you go. So first of all, desolder that bit. That's it. Is there a hole?
I think so.
Good. Right, let's try that again then.
Oh look, there's a bit of solder on the end.
Yeah. Ooh. Right, so that now goes in.
Now do I have to solder all those bits?
Now you have to solder all those bits. Now you could bend the pins underneath to try to keep it in when you turn it over, but it's hard. These are weeny little legs.
Yeah.
And so what you would generally do, if you put a few of them in, I use something like this, just a piece of card, a piece of plastic, put it over the top in order to turn it over so that I can then put it down so they don't all come out.
Okay.
You can do that, which means you could do that on, put all of them in first, so put them in the right way around. Now the other problem you might have is that it's not going to actually fit. The legs are going to be too pokey outy, like that. So, because generally speaking, when you get an IC, its legs are just a little bit splayed, as you can see from that side. So what you can do is you can roll them gently like that in order to straighten up those legs. Roll them just very gently. If you push too hard, you're just going to bend them and then you get into even more trouble. Now luckily we have a little tool that we use to do this, but you can do it just by rolling them gently on the table, but otherwise if you squash them in our little squashy tool, so yeah, put that in there and then you go squash, take it out,
Whoa.
That should just flatten those legs enough so that it should drop into the IC spot on the board. Squeeze, yes. Now try that in this slot there.
Does it mark? Oh yeah.
Now, it has to be the right way around. On the smaller ones, it's got a little dot on it. There you go. Fits in there perfect, like.
Oh wait, do we know which? There's two of these.
Yeah. So are they the same?
No.
So we've got IC2 and IC1.
So that has less writing on, so it'll be like that.
Yeah. Well, let's see if we can do better than that by having a look at the bomb.
The bomb.
The bomb. So IC1 is the big one. That's the Mega controller. IC2 is an optocoupler 6N137. Which one is that? Can you see that?
6N137.
Is that one?
Yep.
Okay, that's IC2. Yeah, that fits alright.
Squidge this one. Okay.
And then the other one should go over there, IC4, which is a dual op amp.
Dual op amp.
Operational amplifier.
Now do I solder all?
So those are all in. Let's just check to make sure they are the right way round. So you've got the little notch on the silk screen, goes to the dot, goes to the dot. This one, yep, goes to the little thing out of the edge, goes to the thing out of the edge. So I'm just going to turn this over for you to save us falling out.
Okay.
So, like that. So just make sure, what I would generally do,
make sure it's not falling out.
yeah, is that you don't want these sort of slightly wonky by leaning on it one side. So what I generally do is do opposite corners. So do that corner and that corner, and do corner, 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 corner.
Yeah.
And once you've done each of the opposite corners, turn it back up the other way just to check that it's not wonky or sticking out or anything gone wrong. And then when that's fine, you can do the whole lot.
Okay, so I've done the corners of every one.
Yeah, do they all look like they're in the right place? Doing the right thing?
Oh, one fell out. I haven't done that one.
So nearly then.
Nearly.
Nearly, not quite. So keep it tight, 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 tight all the time till it's down. That's it. One possible suggestion at this point is blue tack. Apparently it's a good solution for holding things in, particularly ICs and other larger bits and pieces. But I never seem to have any around when I think about it, and then I don't think about it, so I do something else.
Okay.
Cool. Iron away.
Oh yeah, sorry.
Away. So yeah, they look all straight.
Are we done?
No. So now you got to do the whole lot.
Ah, okay.
All the way down both sides of all of them. Careful not to connect any together. So that looks pretty good to me, pretty darn good. So that's starting to shape up to look like a bit of a PCB. So we're getting rid of all the little bits. We've only got a few bits and pieces to do, and then all the chunky bits, which are a little bit more interesting, and start forming the actual machine.
There's not much left to do on that one.
Got to do the crystal though, haven't we?
Yeah.
That was the last bit on this one. So I don't think that has to be one way or the other. Super. Coming along. Next up is the transistor, which is a three-legged fella. You got that? Now on the silk screen you should find a picture of it that also shows you which way round it goes. So stick that in there and bend its legs.
Oh, because it's so it goes like that on the thingy.
Yeah. That's it. Just give them a little bend. Bend one the other way, just so. Yeah, perfect. There you go. Then let's do these capacitors. Now these are electrolytic capacitors, whatever that may mean. All it means is they're a different shape, and they have one leg which is positive and one which is negative, so they need to go the right way round. Now, what does it tell us? One side of the case is a white line that corresponds to the shorter leg. This is the negative terminal. So the shorter leg is negative. Is that what you're seeing?
Yes.
Mm-hmm. So the long leg is positive. So it says that the longer leg goes into the square hole.
Oh, like that. That one. And the square one.
Yeah. So there should be two which are 47 and one which is 4.7. So that's 4.7 you got there?
Yep.
Okay, so that goes in C10. So find that one
This
first.
one, the short one.
The short one, yeah.
Yeah.
Long leg positive.
Oh, yeah.
Okay, because
It said
it said that the other way around.
White line goes in the square, and this is negative.
Let's just go back to that. That's why I wanted to have a quick look. So it said
The
that the
leg.
white line,
Oh.
the white line is negative. Yes, that's right. That's the shorter
In
leg.
the round hole. And you said it the other way.
Okay, the negative terminal should go into the round hole, and the longer leg goes into the square hole. Now that's the problem, because the square leg is actually labelled negative on here.
Yeah.
Just can we see that, everybody? That's negative, and that's the square hole. And the round hole is labelled positive, whereas in the documentation it says that the negative should go into the round hole. That is a bit of a slip up. But if we're going on the label where it says that's positive, then that has to be the long leg, so it has to be that way round. Now, what we'll do, just put that one in there. Where's the other ones? So this is in C16, long leg positive. And this one, is that here?
I don't think so.
But what are we missing?
Oh, yeah, I guess that's the only other one.
Must be that one, long leg positive. Let's go and have a look at this picture here to see whether we can see whether that's right or not. So that is that way round. So that's right.
That's right.
And the other ones are over here somewhere. That's right, and that's right. Yeah?
Yeah.
Okay, so fold those legs.
Okay.
So point of order then, the instructions about telling us which way round the electrolytic capacitors are, the build guide online is actually backwards, but it's labelled correctly on the board. It's just that they mentioned the square pad and the round pad around the hole, and they got those backwards. But just follow the PCB, follow the screen print, and you'll get it right.
Solder time?
Sure, yeah, why not?
Okay.
Sorry, am I putting you off? As you get more stuff under the PCB, it gets less stable, which is why using clips like this can be helpful.
Yeah.
I just don't find these hold anything securely enough. I find it just pushing away from me. But anyway, you just need to apply some pressure with a soldering iron. That should clamp it down.
Are those
One in the
connected?
middle?
Because they have like black stuff.
Now the black stuff is flux. Flux is a chemical inside the solder that helps it to flow, but it's not conductive.
Okay.
So that's okay. This middle one here, have you done those?
Yeah.
Have you?
Yeah. They all in.
Flipping awesome.
Okay, there we go.
Cool.
What do all the lines on the board mean?
These are the virtual wires that connect the components. So when you print a circuit board, you're essentially printing lines of conductor, so wires if you like, from around the place. So if you'd built this on a much simpler way, you would line up all your components and you would solder wires onto one leg and a wire onto another leg and do it that way around. You could have everything just built on a big mass of wires. But this simplifies that by having the wires on the board.
Cool. Now,
so mini USB socket.
Is that this one?
I reckon. So that must be the thing on the end. Yeah. Just another point of order, I suppose, because I'm trying to review this as we go along, and I would just suggest that people putting together build guides, that when they do, I mean, the images are brilliant, the descriptions are good, other than that capacitor one, but just the one little step further would be to put on that part of the build guide what it is called on the PCB. Because this says mini USB socket, and to find this on the board we can make the assumption that it's that because it kind of fits it, and that's right, but it's labelled X1, so why not put on the build guide X1, because that's what it is in the BOM. And with other things I've had to go back to the BOM, rewind all the way up the build guide to find out what the actual component number was that's printed on the PCB. I mean, it would be difficult for you to put those in the build guide later on because you are talking about those components, if you see what I mean. So that just would be an extra nice thing, just so that we can be not having to forwards and backwards through the build guide. Now I reckon you're going to have to just solder them one at a time, because if you try to turn that over with that in as well, it'll fall out. So just turn that one over, solder that, and then do the next bit. Now if that's not going to work, this is where soldering from underneath all falls apart.
Yes.
And why soldering from the above can be a good idea. But, I'm sticking with it. So what we do is you stick that underneath. And that helps you hold it up.
Okay, cool.
Yeah, so I'm just going to hold that down. Now these look really small.
They are really small.
So you're supposed to solder those
individually
without them
they only need a tiny
connecting.
bit.
Yeah. But also with that, I would suggest you can't solder it from the top. It would be impossible to, so you have to solder this one from underneath.
Oh yeah.
Well, anyway, so we're going to hold that like that, and I'm just going to hold that straight while you do it without somehow managing to stab me in the hand.
So I need to use a tiny amount. Might have just done it. Maybe. Kind of.
Well, there's something on there.
Is it connected?
Yeah, I mean, they don't seem to be shorting.
Shorting, what's that?
When you cross from one thing to another, it's called a short circuit. So you short something. It gets shorted.
Is that when you say something short circuited?
Exactly. Because you're bypassing something, making the circuit shorter.
Might need that thingy again.
Yeah, use a thing. Yeah, that works. These need quite a bit of solder because they're much bigger, which means they also require a bit more heating, but see how that works. If you can get the soldering iron sort of, let me just show you, sort of a bit into both. So you're pushing against the leg and holding it. Try putting the solder on now. See, it's not quite heating up enough. There we go, that's better, isn't it?
Is that enough?
Probably, I can't see. Yeah, it looks good.
Okay. Yes.
So you might need to adjust it a little bit so that it's heating everything up that you need it to heat. That's good. Next thing, MIDI plug.
MIDI plug. Oh yeah. Do I need to solder those holes?
Well, not if there's nothing going through it. They must be superfluous.
Okay. Okay.
Great. Great. I reckon we'll finish this board
And then
before before you have to go off and run off with your mates.
Not actually run off because that's illegal.
No, yeah, we're not running anywhere at the moment, but in a virtual Xbox style-y, you're going to go out to play. So, that's good, that's right. See, look at that. It's like a real thing. Right.
Do they get robots to solder all that stuff in real life?
Not like this, not through hole, but things that are mounted on the surface of things, then yes. So we've got these headers. Now these are for connecting the two boards together.
Oh.
So they actually move signal from one place to the other, and they go in which way round, that way round, or that way round. I don't know, we'll have a look on the board and see what happens. Probably that way round, because they're going to need to squish in. I wish I hadn't done that now, because I'm not going to be able to get that undone. Yes, I am. Okay. So on here we're going to need to put these. Now this also highlights another point I'd like to make, which is we should have done these bits before these bits, because this is higher, and in my method of doing it, which is to do it from the underside, because how can you solder? Tell me how you can solder this from the top, because you can't get to it if it's going to be flush. Therefore you're having to turn it over in order to solder it, which is what makes sense. In which case we should not have put this on first, because when we turn it over it's going to fall out. Because the general, as far as I can make out, the accepted way of doing things on a PCB is to start from the lowest stuff, go into the tallest stuff, precisely so that you can turn it over to solder it without the bits falling out. So this puts us in a bit of a disadvantage, where we're going to have to use something in order to keep those in. I mean, alternatively, we have to hold it up and somehow solder it underneath while it's suspended, or I guess we can go back to the using blue tack thing, but I much prefer for it to be solid.
Would that be the same?
That's not going to quite do it, but 2 bits might. So this leaves us with a slight problem, because when we turn it over, we need to make sure that it's flat, because if you have it at a slight angle, it's then not going to line up with the one that you're trying to put in on top. So it must be absolutely flat. So I'm going to hold this like this. I mean, if you're on your own, obviously you're just going to have to come up with a plan, or desolder the MIDI plug just to make your life easier. But if you do corners again, Alfie,
oh yeah,
then we'll do the other one on corners, and then you can do the rest much easier. There you go, so that's one corner. So we'll do the same with this one.
there you go.
Good. So that looks good, that looks flush on both sides. There's this little one. That must go there. Does that look like the same on either side? Yep. Find my finger. Good. Now, is that all of them on this board? Seems to be 3, but there seems to be a spare one.
No, there are 2 of these.
There are two of those. I mean, one goes into there. There's only one there. That is an upside down one. One of these. They want there. Like so, yeah?
Mm-hmm.
So let's do that as well.
Should I do the rest?
So yeah, solder,
Oh yeah.
finish off those, that side, that side, that side, and that one.
Mm-hmm.
And then that should be that PCB done.
Cool.
Right. Oh, that's all right. Have a look. So switch there. Look. So that's probably that switch.
Good.
That wasn't on the. Was that on the thing? So there seems to be this bit missing, which is the switch. Now we haven't come across that. Have we missed that back through here? It's on that picture. No, and it's not on that one. Right. Okay, point number 3 for the build guide. The switch is missing. What's the switch look like? Looks like this fella here. That little switch. This little thing. That's not in the build guide, but it just appears on the PCB at one point. Now it only has two pins on it, and this, assuming that's where it goes, that must be where it goes. Where was it that we saw it? Here. Now according to that, it's on those in between, not the outside two, it's on those middle two. Right, so one little last bit to do then. Your soldering, my friend, is really coming along. Good job. Great stuff. So we are going to leave it there for the moment. That's been a good couple of hours chipping away at that. So what's left to do is the red PCB, which has just got big chunky stuff on, so it shouldn't take too much time. Perhaps another half an hour or something, but we'll pick this up again tomorrow. Cheers. And we're back. We're back to the red PCB, the top PCB, the hardware PCB, the one that's got all the knobs and switches on. We completed this. It's now a couple of days ago, I'm afraid. But it's all looking pretty good. So this shouldn't take any time at all. Assuming we don't hit any more calamities. And also assuming that it makes noise at the end of all this, because that's going to be good. That's going to be good. So, with the next bit, what we want to do is complete the headers, these bits here, that connect the two boards together, because then we can then take that off and continue soldering. But getting this on here first is going to make the job of soldering easier, so we're not trying to navigate around knobs and switches that are on the top. So to do that, you want to put these two bits and this little bit into the sockets and then fit the board on top. Yeah? Give that a go.
Like that?
Yeah, well, if you put them in there, so long side down, that's it. Put them all the way in. And the little one. And place that on top. There you are. Ooh. Yeah, make sure it's nice and flat. And then solder all this lot. But I would do a corner again, just to make sure that it's right.
We'll be able to take it off after.
Yes, because these bits are going into sockets, so you can pull it apart once it's soldered.
Okie dokie.
At least that's the plan.
Do I need to do something to the tip of it?
No, it looks all right. Just give it a quick wipe and wipe in there and a dab in there. Make sure it's good. Here's your solder.
Okay.
Get stuck in. Brilliant. Yeah, see if you can wobble it apart. Great, so that should easily go back in. Yeah?
Yep.
That's the plan. Now the build guide is suggesting that we do the pots and the switches next. Now the point about this is that if you put a pot in, and then attempt to put the LED in, then when you turn it over to solder it, that's going to fall out again, which you don't really want. So you need to do the things which are lower down first. So in my view, I mean, all there is now is the switches and the pots and just the LED. So I think we should do the LED first. Now, sadly, I don't think that's labelled. Right, because the thing with an LED, right, is it's a diode. So a diode only goes in one direction. So if you have it the wrong way round, the whole thing doesn't work. It has to go in the right orientation. Now, normally speaking, on a PCB, you would get, under here, a positive and a negative sign printed on the silkscreen. However, there ain't one. So let's see what this has to say. It says the LED needs to go the right way round. Plastic casing has a flat side which corresponds to the shorter leg. Have you got a flat side on there? So
Yes.
look at the base of it. Right. So actually you can see here on the print that it has a flat side there. And in the picture that also corresponds to the flat side. So find the flat side.
There.
Okay, so that needs to go facing that way and that'll get us around the right way. Great, so that's that bit out of the way. Now what's going to stand taller, the switches or the pots? The switches. So let's do the pots first then. So you can see pots is short for potentiometer, which is what this is. It's essentially a resistor, like these little blue resistors, but with a knob that allows you to change the resistance. So a variable resistor. The old-fashioned name is a potentiometer.
Okay.
So they can only go one way round. Got 3 pins here and then 2 I don't know, holder pins, earth pins, whatever you want to call those bits. So you just need to wiggle it in and then push it so it's flush down like so and pointing through the other side.
Okay.
So yeah, stick them all in, then turn it over and solder.
Just the switches.
Switches can go in any way round. So they literally just drop in there. Now of course these are going to fall out when you try to turn them upside down. So you're going to want to, well no, look, that works quite well like that. I mean, you want them to be as flush as possible, but because of the way they are, that's never actually going to happen. So you could do them, you could probably put 2 in there and do 2 of them at once, just see how that works. You know, use bits of stuff to things, and there's other bits over there. Do you want me to hold it?
Yes, please.
Okay, I could do that.
Cool.
Check all solder joints are sound. Have a look at them and go, oh yeah, I think so. Check and remove any solder bridges, especially on IC legs. So bridges is when it's shorting out, because that, if it could break it if it's if they short. Ensure the IC's the right way round. Yep. 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 Use a multimeter and check for shorts between the 5V and ground pins in the centre of the board. 5V and ground. This needs to be done with both PCBs connected, so you might need to do this from the bottom. Well, yeah, I think you probably will. So put them back together, we'll get the multimeter out and see if we can do what it says. So, turn it upside down. So I think what it's saying is that those 2 points there, they shouldn't be shorted. If it's shorted, it means that power's going from positive to ground, which means it's just disappearing, it's going nowhere. So we use a multimeter on make noise mode. Yeah, no, that's not it. What is it? It is that one. What do I need to do? I can never remember. Never remember. Function, there we go. So if there's a short, so this on mode here, this mode here, if there's a short, if there's a connection, you get a buzz, a tone, a beep, yeah? So if you can put one on each of those holes, let's just put it down like that so we can see what's going on. See whether it beeps. Yes, success. That means we haven't shorted it out. Put them together. Perfect. Great stuff. So now it should just jolly well work with a bit of luck.
So do we just plug
You're
it
ready to power it on. All the code is ready flashed onto the thing, so it should just work straight away. Connect a mini USB to the power socket. So plug that in to one bit. Ready?
Yep.
So this is the point what we call the smoke test. Hang on.
So will there be smoke?
Well, the point is that there shouldn't be smoke. If there's smoke, that's a failed test, is the idea. So, go. Oh, wow, that's bright.
Okay, now what?
Dunno. What does it say?
Connect the output socket to a mixer.
Output socket.
Connect a device capable of sending MIDI data to the synth.
Okay, and
Do
it
we
will
need to
blink
do
as it
that?
receives it. Well, let's just have a quick look. See whether we can get it to make any noise without. And no, it doesn't look like we can. There's no sort of drone ability, so we're going to have to find some MIDI from somewhere. Okay, stand by. Now, sadly, it was at that point that things kind of went a bit horribly wrong. Our board, as it turns out, was just a bit of a dud. We worked with Rob at TSSSS to work around a few things. Yeah, we did some bodging over here and some connections over there, cut a few bits here. We got MIDI in to work, but we never actually got any sound out. So sadly, we kind of had to put it to one side. But Rob did send me a replacement board. In the end, I've been able to put that together. And now I have the thing working. And it turns out that it's quite a fun little synth. Well, of course it is. It's the Meeblip thing, which is great. It's a great little synth. It's just a barrel of fun inside this little thing. So it's a great little build. Now, I'm not entirely sure anymore if TSSSS still exists in the business of supplying kits. I mean, because of COVID and the lockdown, also all of the workshops that they used to run in order to build these sorts of things have obviously not been able to run. And so at the moment they seem to be just, dumbed down to a social media channel, and that's about it. But I'm sure if you get in touch, you never know what you might find. But what I think that this video has been about is just to demonstrate that soldering is fun, it's easy to get into. Soldering together synthesizers is probably the best thing because the end result is so potentially awesome. And it also illustrates that it's not always successful. You know, you sometimes get to the end of a build and the thing just doesn't work. Sometimes it's something simple that you can find, you can track it down just through very, very careful observation and looking through all of those solder joints and maybe trying a few of them again. Or you might have got something wrong or backwards, you know. And most of the time these things are fixable. Not for us on this occasion, but never mind, that's just one of those things. But there are plenty of little synthesizer kits out there for you to try on. You don't have to get something enormous and complicated and expensive just to give it a go. I also would highly recommend doing it with your kids, getting them involved, because, you know, particularly once they're getting towards high school age, using a soldering iron is something that they should be able to handle without any difficulty, and giving them the opportunity to see behind the shiny boxes and shiny cases that things usually come in, and to get into a little bit of electronics, I think is awesomely worthwhile. And I hope that Alfie will do some other projects just as soon as I can find things that I don't want to do myself. That's the only problem, is I want to do them. It's too precious. So anyway, I hope that's been helpful. It sort of felt like a run through of how I approach soldering, and it was an opportunity to talk about the different things that you use and do, and how it all kind of comes together in the most friendly way possible. And if you want to get deeper into building synthesizers and perhaps Eurorack, then do check out the rest of my channel. I've got an increasingly vast amount of kits and stuff and content that I've built around building this sort of stuff. And it is probably my favourite thing. It's my favourite thing at the moment, and I'm pretty sure that comes across. So, in the meantime, go make some tunes. I'm going to make some tunes out of this little fella.